Hossein, you're on.
Okay, all right. So I just wanted to mention this presentation is going to be a bit biased, or maybe a bit more than a bit biased towards structural engineering, because that's who I am. I'm a structural engineer. But I will definitely touch on the technology aspects towards the end. But I just want to kind of go over what I do and then how it, what part that or structural engineering has in construction, and then kind of we go from there, I think. So I've prepared something a very simple presentation, but we'll just kind of start. So that's who I am. I'm Amir's brother, Hossein Bajehkian. I'm a structural engineer. I work for Reed Jones Christoffersen Consulting Engineers, which is, and then our work is in the building sector. Pretty much like most of the buildings you see in downtown Vancouver, we service, or many others in other cores like in Burnaby, and pretty much like any building that you can think of, we probably touched it. And we provide structural consulting. And with that, I will just start by saying, like, what does a structural engineer do? And I used to get this question a lot when I was in my 20s. You know, you would go to a party and nobody knows what a structural engineer does or who they are. And then all I would say is we just make sure the building doesn't fall. Like that would be my answer. But if I was going to put that in more formal terms, I would say that we design the primary and secondary structural systems to ensure safety of public and building occupants as per building code guidelines. And there's always two systems, one to resist the gravity loads and the other is the lateral, which is for earthquake. So you always make sure you have enough, your floors are rated enough to take the load that it needs to, and also you have enough lateral bracing systems that's enough for earthquake. And then I'll kind of go over, like, I guess, how do we do that? And that's, I mean, at first I thought it was simple, but it can get quite challenging because there's a lot of variables in what we deal with. Like it kind of looks like just arrows and, you know, numbers, but what you get on site and in the field can vary quite substantially. But basically the idea is to make sure that any load has a safe path until it gets to the ground. And that's really, if we were going to put our job in a nutshell, is we just want to make sure that's happening and it has sufficient strength and serviceability criteria. And serviceability means that like your floor is not sagging too much, because, and we have criteria for that, and if that's violated, then what happens is that the building occupants are going to feel distressed, and they're going to think there's a structural problem, or they're going to think that the building is going to collapse. But more often than not, it's not going to collapse. But just the fact that there is a distress, then that's an issue. Load paths can get complicated, as you can see here. And that's, especially nowadays with modern architecture, like we have to get really creative on how we justify that these systems are safe. You know, like how can you make things like this work out safely? And we can do that thanks to advanced in material engineering, that now we have more versatile and high strength materials that allow us to design these kind of structures. And then I mentioned building code, and then that was I guess nobody really, I don't know if anybody ever talks about building codes, but for us is probably, like, if not the most important thing, like one of the most important things that we deal with. And like, I guess, what is a building code? And this is a Wikipedia basically quick description that just basically, excuse me, basically like what the standards that's been developed to ensure mostly standards that are required to build buildings that are safe and protect public health and safety and general welfare as it relates to construction and occupancy of buildings. And this is not just structures. So there's in relation to mechanical, plumbing, building envelope, electrical, all of these have their own building code requirements. And if you probably all of you are currently located in a enclosed environment, and if you're just feeling comfortable, and I guess maybe you're taking it for granted, that should mean that hopefully your building that you're in is built according to building code bylaws. And when it doesn't, then you're going to notice issues that you don't know why, but probably because there was a building code violation. Sometimes building codes can get, I mean, a little history, like I kind of found this interesting that building code was mentioned in the Bible, that, like, for instance, parapets at the roof need to be constructed so people just don't fall off the roof, which sounds so simple, but like sometimes that gets overlooked. So what are the challenges that I mostly notice with what I do is when it comes to building codes, when it comes to ensuring proper load path and life safety, is that the difference between structural engineering, I notice, and other engineering perhaps, is that, or maybe most others, is that you really, maybe structural engineers have been around for like 100 years or so, but buildings have been constructed, I think I heard maybe for the past like 7,000 years. So there was really no structural engineer for most of this time to tell anybody how to build anything. And so how they were built, just based on traditional approaches, and determining whether whatever it was built, which is quite a few, and whether that's safe, is almost becomes like it's like a judgment call at certain situations, because you get to see a lot of situations and methods. And also in modern times, you deal with, because these structures are built by competent trades that have developed their own traditional approaches, and they don't necessarily, they're not quite maybe like building code savvy, and they don't, they just maybe like to do things the way they do. But at the same time, they're the only ones who are doing it. So you kind of have to work with them to reach a compromise and build things that they are able to build and at the same time are code compliant. Also, like, there's a lot of coordination with other disciplines like architectural, mechanical, electrical, building envelope. And I guess there's a typo there. Anyways, that you would need to know a lot about a building to sort of be able to address all the challenges that come in the construction process. Like when a building is getting built, there's so many aspects that are involved, and there's so many professionals that are involved in each of these disciplines that you would need to coordinate, and then your structural design might get compromised, and then you have to find a way to work around it. Like this picture on the left is probably the situation I deal with like every day. Like I get calls like this gentleman over here, and then it's just something's happening, and then I get issues that, you know, like things that are challenging to build a certain way due to unforeseen conditions. And that's the other challenge with just the construction industry in general, is you're always dealing with unforeseen situations. Especially when you work in existing buildings that have been built, say in the last 50, 100, even 200 years. I mean, we don't get to see a lot of those, I guess, or at all those, because Vancouver is quite modern relatively to other cities. But generally speaking, anytime you deal with an existing building, when you open things up, then you notice that like you're seeing things that maybe, I don't know if anybody finds this unsettling, but you would call this definitely non-code compliant, as an example. So that's kind of, I just try to kind of like wrap up like I guess what I deal with more on a day-to-day. But going into technology, so all of that said, and I think I was more biased towards the design aspects of construction. There's a lot to be said about the construction aspects, and I think maybe maybe some of you were looking forward to that. But when it comes to, I think construction, at least when it comes to design and even construction, the issue, the technology that's involved, like there's two aspects. So there's the design aspect and the construction aspect. In the design aspect, you would need a lot of softwares for analysis coordination. We deal with a lot of PDF document because of, I guess, the stability that they provide, and you know, they kind of form like legal documents. And construction is in such that when you maybe sign off on something or any kind of document, you're basically signing off on a large amount of energy and human labor to be expended. So there could be a lot of liability claims from these documents. And like I mentioned, because there's a lot of information you're dealing with, and the information could be coming from just variabilities that exist in buildings, in say a plumbing system of a house that you've never seen before, the ground that's never been excavated, and I guess thousands of buildings that exist. I think the challenge we're having right now in the construction industry is how do we use technology to, I guess, communicate and coordinate this information to the designers, to the trades on site, and so that we can build more efficiently and more effectively. And a lot of, I guess, a lot of construction effort, I feel like being wasted on just not having the right information, or a lot of, like in terms of efficiency, a lot of times maybe the construction contractors on site waiting for information to be delivered because we just don't have advanced software that would allow us to prepare the drawings or prepare our analysis in an efficient and way that we can get them the designs so that they can just start working. So there's a lot to it. And then on talking a little bit about the construction aspect of technology, I would say it's fairly, I think to my information, it's fairly new. Like I kind of run out of time, unfortunately. I was trying to find some more images of this system that's been developed where there's a robot that actually kind of builds a concrete wall, and then you kind of feed it a program, and then, you know, eliminating the needs for human labor. But that's, I think we would need a lot more advancement in robotics before we can get into that. Most of the technology that's facilitating construction at the moment comes to, it's more like soft technology. It's more like softwares, you know, for analysis, coordination, not so much like hard construction where you have a technology that would build something. And I think that would be amazing if that can happen. And just because you deal with a lot of uneven, irregular surfaces of, you know, all kinds, and you're exposed to very intense environments when you're performing construction, I think we still need some time until we get to that. I guess I will stop for now, and then I might, maybe depending on how it goes, I'll talk a bit more, but maybe I'll just kind of open the floor for any thoughts or comments or questions. And yeah.
Do you want to keep the slides on, or is that it?
I don't have to, but they can. Either way, I'm okay.
Sure, we can just close it.
Sure.
Awesome.
All right.
Yeah, let's do the group photo before we get to the discussion and questions. So Sam and Nilufar. Okay, awesome. 1, 2, and 3. All right. Okay, the floor is open. Go for it. Somebody was asking for $100 million building. I guess that was Mohsen. Oh, Jennifer raised her hand. Jennifer.
Okay. Yes, I would like to know more about that.
Yeah. So one of the things, like up until quite recently, public buildings were, the requirement was to have them built to the LEED Gold standard. And the big conversation we're having right now is net zero ready. And one of the things we're struggling with is code compliance, the difference between net zero ready and actually net zero, and the intersection between net zero in terms of like energy consumption once the building is built and running, and then how to build the building to a net zero standard with construction materials that will like support seismic. It's a really big shift right now in terms of public institutions interacting with structural engineers, architects, and the provincial code. And I was just hoping that maybe from your perspective, you could talk about that kind of transformation in terms of like energy conservation and environmental responsibility, and getting to integrate those into our building codes, and how that works from your end. Because I'm telling you, from my end, it's been a big shift.
Yeah. I would say like these things are very hard. Like everything, just everything is hard in construction, unfortunately. But these things, I guess in particular, there's a lot of developments, I would say already. Like there's a lot of new technology in all disciplines. Mostly, I think the most spotlight goes to HVAC and mechanical engineers and their heating and ventilation system, because those are what really saves the energy. And also envelope, like, you know, they come up with like new ratings for exterior wall insulation, and fortunately a lot of architectural firms, including the one I used to work for, which is Dialogue Design, they're quite proactive. They even I can't remember if they had something they were saying that they want to, I don't know if I might be mistaken, but I remember they were saying something about like they just don't want to design any building that's just not net zero or something. And then, but it's really hard. The clients are really going to push back hard on this, because these things are generally very costly, and you know, and nobody wants to pay for it. And if the client pays for it, or if the developers pay for it, then the costs will trickle down to, you know, the occupants or the homeowners or whoever is going to end up using it, or the renters. So that's the challenge. Like, how do you absorb this? I think that's really the most important challenge, is like, how do you, because everybody's going to end up paying for that. And maybe the amount of subsidies that needed to accommodate that is the big question. Yeah. I hope I touched on what you were asking.
That was great. It's a big topic, right? It's a huge topic. And in public construction, it's slightly different because, of course, you're not looking to do, immediate cost recovery from, like, say, retail sales or tenants, but you are trying, like, every dollar that you use on construction is a dollar that doesn't go into, like, the business of education, like the actual teachers. But you can look at it as sort of like amortizing the cost over, like, the 40 or 50-year lifespan of a public school. But it's still really tough to balance those decisions. And there, like, I will say, the intersection between people who want to build to net zero and people who have experience building schools, it's like a small subset, right?
Oh,
right now, but
right.
yeah,
Okay.
small overlap right now, but it's getting better, right? And certainly, government funding, I think you have hit the nail on the head, right? Government funding is what's going to make sure that public buildings can do that. And that, I think, Hossein, we should put you in front of some MLAs and have you talk to them.
All right. I appreciate it. I don't know how good I'll be, but I'll say, like, I think another thing about that is subsidizing sustainable technology. I think that's huge, because the less subsidized these things are, the more expensive the material is going to be. And there's a lot of materials that's being developed. Like, I heard about, just recently, I heard about this sounds crazy, but I actually think it works. They're making, like, blocks out of recycled paper, like structural, like that actually have some level of structural capacity. And these material are very, like, we call it ductile, which is a fancy word for flexible, which works really well for earthquake, basically. So that it has that kind of feature. And but yeah, like, anytime you talk to a client about trying to, add something that's sustainable, that they immediately say, like, how much is this going to cost? And yeah, then it gets challenging. Yeah.
All right. Mohsen, do you want to jump in?
Yeah, I have a question. So I've studied civil engineering for my bachelor's, and I have, like, I never worked in the industry, so I have some vague things I remember from studying, like, 15 years ago.
Mhm.
And there was in the concrete design building course, there was something like for every story they build, they need to let the concrete dry, the cast dry for, I remember, like, 21 days or 20 some days.
28 days. 28 days.
28. Oh, okay. So my question is, does this time still, do we still wait this much here in Vancouver, or are they using advanced technology to reduce the amount and, like, build faster?
No, they don't. They definitely they would go nuts if they had to wait that long. But so the 28-day strength is still a standard reference for concrete strength, which we always use, because I don't know if that's I think it was like 95% of concrete strength is gained at around that time. So that's the long-term strength. But there's concrete material nowadays that are high early strength. So you can gain that strength in a matter of 3 days. So then you can build faster. But even then, other than that, like, what happens is say if you're building a floor, then you're gonna put shoring underneath it, and you only need, say, like I think it was like 16 MPa strength before you can do that. So then that can be done within like a matter of days. And then while you're working, you're building your floor up. Then by the time you're taking everything off that floor, it's already been 28 days. And you're probably at that time, you're 4 floors up, because it's a common cycle in Vancouver to build 1 floor every week.
So they're pretty much faster than what I thought.
Oh yeah, definitely, like, yeah. Speed is the name of the game. Like, everything is always needs to be fast. Because construction translates into real estate, and then if your building is not ready, then you can't charge rent, and so
yeah, you're wasting capital then.
Yeah.
Right.
Yeah.
And another question about this new wooden frame buildings, that there's one in UBC. I haven't seen it, but I've heard like 20 something floors. And what do you think about this trend? Is it going to be the new? Is it going to take the place of concrete buildings, concrete high rises?
Yeah, I mean, I wouldn't be, maybe I wouldn't claim to be very knowledgeable on the sustainable aspects, although I've heard that's basically the trend, is wood is the sustainable material compared to concrete because it doesn't have as much carbon emissions. So that's, and I love wood. I think it's great, and I think it has a lot of potential, and it's great to work with. Although there's a lot of challenges, like when you're building something that tall, then it's not going to be especially with wood, it's not going to be as laterally stable. So a lot of the times they build a concrete core still inside of it, and they attach it to the concrete core. And they've also come up with, they call it Clt panels, where your whole floor, like the traditional construction, you would have joists like every 16 inches. You just put a joist, like a beam. But now they just have an entire like module of floor that they've kind of glued together, and those are also getting a lot of popularity. But wood cannot be, I don't think it can ever be as good as concrete or steel. Like, I mean, at least not anytime soon. I think if you want to build like a 60-story building, like, I don't think you can do it with wood. So, yeah.
Right. Thank you.
Thank you. Well, we have Saber joining us just right now. Can you introduce yourself, Saber? Tell us what you do.
Yes, hello everyone. I'm Saber. I'm just graduated from Dalhousie University. I don't know if you guys are hearing me well or not.
Yes, we're hearing you loud and clear.
That's cool. Okay, perfect. Yeah, I graduated from Dalhousie University with a master's degree in structural engineering. And yeah, right now I'm looking for like engineering job. I just found this event like interesting for me to have some like valuable information about this market probably. Yeah, and I think I was like half an hour late, right?
Well, yeah, but that's fine. No problem.
Okay, hopefully I haven't missed any like information. But yeah.
Are you in Halifax now?
Yeah, I am. Yeah, in Nova Scotia.
Nice. Well, that's 4 hours ahead of us. So, good evening there. Okay, yeah. Sam, the floor is yours.
Yeah, I have. Thanks, Hossein, for the presentation. A few questions about technology on the topic for the session today. I'm just curious to know what are the technologies that are recently used in both construction, building a new building, and also inside the building. It could be, what are the technologies that are interesting and you see the future, for them? And you've seen that they're used in Vancouver.
Mm-hmm. Oh, there's I guess it's quite a, like, depending, it's quite a diverse, there's quite diverse set of technologies that exist. Like, let me see. I would say, like, in terms of like what I'm aware of, like the recent developments would be, like, say, in terms of glass. I think there's been quite a bit of advancements, like in terms of glazing systems. Like, you're able to see, like, glasses that are, because that's just a popular thing. Like, everybody likes to see like a glass that's like super wide and there's no mullions in between. So I think the glass technology has quite expanded. I think there was an Apple store that opened up in China or something, and they had like this whole glass atrium, and so that's one thing. There's, in terms of like what I'm more aware of is more like in terms of construction information technology. There's softwares now that you can do a lot that you couldn't do before. Like, you can do like your material estimation, quantity takeoffs, structural analysis, even with softwares that are modern, and they give you you know, results quite effectively. Like, the thing with construction is the information is not quite, like, the information we deal with is not very, like, it doesn't need to be manipulated a lot. Like, we're just dealing with, like, say, areas, you know, square foot, mass, weights, and that's really all you need to get your prices, and that's really all you need to get your like quotes for your project. And I think that before, like, we didn't have any of this, and there would be a lot of like, you would have to use, maybe you would have to write down everything, but the softwares, the modern softwares, allow you to maybe like upload a drawing to that software, and then you can like outline the area, get the square footage, all of that. So that's in the software aspect. Another one I mentioned, I don't know if I can find it, but there was one that, like I said, it's a robot that's able to kind of lay out cement in layers, and then kind of just produce a concrete kind of maybe like basement wall, and without any kind of human intervention. So that's another one that I found very interesting. I think there's been some HVAC systems that are more modern and sustainable, but to be honest, I'm not quite familiar with those, so I don't want to, I guess, say something that I wouldn't know too much about. What else?
So from your industry, like, you know, like Vancouver, one of the things that Vancouver is famous for is like housing issue, housing problem.
Yeah.
Like, from your industry, how do you see that problem, or how do you think that your industry could help to, you know, reduce that, or like minimum, you know, to improve that issue?
I think, well, this is just a personal opinion, but I think that a lot of construction that's being done is more like luxury construction. So that's maybe there could be more effort in providing more masses of housing rather than providing a luxury, concentrating effort into like one or lesser luxury units. So that's something that needs to be addressed. Like, a lot of, like, I love sophisticated kind of construction, like, say, Vancouver House. I don't know if you guys are familiar with that building. Like, say, something like that is gonna take a lot more effort to design and build. The structural requirements to make something like that stand is quite high, and just the technology involved, like the way that was built is using post-tension cables in the in the concrete core, and so these things are not very common. So I think if we want to help housing, we would need to keep it simple, so then we can build faster. But at the same time, you know, I think there's a balance, because if you build things that are very modular and just build like tons of units, then the city is going to start looking maybe unaesthetic, right? So, but I think if we can balance maximizing our construction output, but at the same time keep the architecture in there, I think that we might have a kind of a maybe the most efficient solution that way.
Thank you.
Thank you for your question.
Thank you. Yeah, speaking of Vancouver House, actually, it's been in the news for like recently about, was it flooded or whatever?
Oh yeah, I heard about that. Yeah.
You want to talk about that a little bit?
So,
Trash
how
talking
that
Vancouver
happened,
House.
but it's, I mean, I would say it's probably workmanship, which is something I actually wanted to mention, that one of the things that technology actually can help with this is because the thing about construction, and maybe somebody from outside the industry might not be quite aware, is the oversight. Like, there's a lot of hierarchy going on. There's obviously the owner or developer funding, and I'll get to what you're saying in a second. But so there's that, and then there's the consultants, the contractors, the construction, project management, and then all the way down is the trade. And then even the trade foreman has its own junior laborers. So those are the ones who are building, actually, like, you know, getting their hands dirty. So all the way from the top, like it's really hard to see what they're doing exactly. So what this comes in, I would say it's more of probably a workmanship issue, where something was just not placed properly, and then you get all kinds of issues like that. And it's always very tough to, I guess, see everything as it gets built. So technology is, in my opinion, what can help with that, like providing a system where you can utilize technology to perform field reviews, to make sure you're doing proper quality control on what's getting built before you put all the finishes in and then you can't see anything. So in that case, maybe the piping wasn't, like, say, plugged properly, or I think I didn't read into it, but that's a lot of the times that's how these issues are caused. And then when the issue is caused, and then everybody's just going to point fingers at each other, and which is probably what anybody in that situation would do. But I think the main problem is that first of all, how do you allow that worker to, how do you help that worker to do a good job, and then at the same time, how do you oversee their work? And yeah, and I heard there's these robots where they kind of, it was mentioned in some of the tech conferences in San Francisco, where they would just walk around site and kind of just have a camera on them, and then they could detect code non-compliance issues. So that takes a lot of, I think, AI to get stuff like that done. And I've been looking into it, but I find it really challenging. But I'm hoping that we can get that done, because it's really challenging to, like I said, just know things, know where the pipe is, know where the beam is, if they put enough rebar, like the welds are done properly. There's just so many things that need to be done as per code, and these codes are just getting too, just too many rules, right? Anyways, I digress.
It's in terms of, like you said, that back to the affordable housing in Vancouver, it should be simple and not complicated. But in terms of the type of story, like, have you heard of anything in terms of number of the stories, or like in terms of the economic, that they financially make sense, break-even point? Like, or
Oh yeah,
the
like
higher we go,
dense, yeah.
in terms of the cost, the higher we go, is it cheaper, or no? There is like some break-even point.
It's tough because it depends on so many things, but and the site, it depends on site condition, it depends on like the height. Yeah, obviously, I mean, you could just say that as the higher it goes, it's going to get more expensive for a variety of reasons. Like you need to re-anchor your crane like every, like, say 10 stories. Like then that's one thing. You're like pumping concrete, like once you get to like 30 stories up, then that becomes a problem. Your heating and ventilation system are going to be just the routing of that is going to be an issue. So yes, I think if you want to build something that's, I think if you're getting to a point where you're building like over 100 stories or so, then you're adding cost. Maybe you don't need to do that, but because some people, it's nice to have the tallest building in the city, or but in terms of what's that optimized point is, I would say it's really hard to say. But I would say like maybe a 20. I'm guessing it's probably around 25 stories. It's like you can get that done without too much complications, I would say. So if you're living, if it's a dense urban area, like I would say you want to, if you don't go tall, then you're wasting space, right? So I would say around, I'm guessing it's probably around that.
Awesome. Well, at this point, I usually ask the speaker to think about what the takeaway should be. You don't have to answer it now, but I'll ask you again at the end of the session.
Oh, okay.
So yeah, you have like half an hour to think about that. But in terms of like affordability, like how much can construction contribute to the price of like how much can it bring it down, like in your opinion, like give or take, if you have any number, like how much more you can do, or people in your company can do to reduce the prices, and whether or not they're doing, that's a different story.
Well, I mean, yeah, like that's all, like it's like I said, that balance between, you're really asking like how ugly do you want your building to look, really? I mean, like if you don't have any, like imagine like a garage where they just have block walls maybe painted and then they just have a steel roof, that's probably going to be very cheap. But if you want that to have proper insulation, and you have to, I mean, if it's a residential, like you have to by code. And then, but I'm just saying, just the more you need to do to that space, the more it's going to add cost. If you're going to put flooring is going to cost. I think it ranges, say, from $2-3 per square foot to like $15 per square foot. So if it's a luxury condo, it's going to be on the high end. So then that's going to add to the cost. If your same goes with like every single other piece that goes in there, from the appliances to the counter. You want to put a granite stone, or are you okay with some, like, I don't know, like wood, plywood, laminate, whatever. Usually with the basics, the cost doesn't really change, like unless you have an irregular structure or system. Usually, like, doesn't matter, like if it's a luxury house, the structure is going to cost the same, the plumbing is going to cost the same, the electrical. But what adds to the cost and causes what affects the affordability is, like, you want to, like you want to say a free, like your window to be like double bay window, like without anything in there. Like that requires special engineering to accommodate, and then like satisfy that serviceability criteria above that I just mentioned in the beginning. Like these are what really adds to the cost and affordability. So if we keep things simple, then it's just going to cost less. If we, the more complicated we make them, then it's going to be less affordable, right?
Yep. Jennifer?
Thanks. This is really interesting to me because I only ever get to talk to the architect. We never get to talk to the structural engineer ever, right?
Oh.
So this is really interesting to me. One of the things that I think we explore a lot is, we're kind of on the edge of figuring out how to use those big giant glass, pieces in schools, and there's a struggle between the affordability, environmental sustainability, the structural strength, seismic, all that stuff, and the actual livability of the materials when it intersects with children. So one of the things that we discovered, like say the difference between building an office building that is all glass, which is, beautiful and light efficient, and is that building a school like that makes kids really unhappy, like really unhappy,
Yeah.
like super anxious. They hate it. They hate the open floor plan where people can see them all the time, right? Because they're teenagers and they're super self-conscious. They don't want people looking at them. They want their classrooms to be little boxes, right? So people can't see in. So how much conversation is there right now about the newer materials, the newer technologies that are being put into place, and in construction, and the livability of those materials once they get to the end consumer, especially children?
Right. Okay, let me digest that. I guess from a structural point of view, we don't get to, I guess we don't get to be very creative. We just have like concrete, steel, wood, but we do, like in terms of material, like I think we are, sometimes like an architect might ask us to design a wood building just to satisfy that net zero, or, so that's where the material comes in. And I think for us, where we get to kind of impact the livability is how, through this trend of exposed, like this architectural trend of exposed structures, like, architect wanting to highlight the structure rather than hide it, because traditionally you just want to put drive-all over it and not see it. So with that, I think then we're in there, like now we can't hide anymore. Like we got to make the braces look nice, or, it's just so that it's more, it doesn't make you depressed when you're just there. And I think that's where we can make an impact. The other thing, but mostly the impact we make as structural engineers is just by being less visible, like as much as we can. So there's that. And also, I think the impacts we make are subtle. Like we allow maybe a large span, so then you can get more light. But you're not really thinking about the structure when you have that wide open window. But that's how, because the beam was engineered to take that, let's say, and that I think that affects the livability, because that was made possible by the structural engineering of it. And we get a lot of we get a lot of turnaround from at the concept stage from the architects. Like, they come and say, I want this kind of school to be done this way because of that, and then it's about making it work, right? So I think that's how we contribute, and I'm happy that we're able to do that as much as we can.
That's good. Thank you.
Thank you, Jennifer.
How did the pandemic affect your industry and your work? I
think it just made us more busier, I would say, which is fortunate, but that's kind of a lot of the renovations, and just upgrades or whatever they needed to do in the commercial buildings. It was the best time for them to do it. You know, change their generator, renovate their office space, whatever cleanup that needs to be done. That, yeah, like that. That's probably, yeah. That's most of. I would say, like, yeah, I've gotten busier since the pandemic happened.
So let's, shall we say, like, other than Pfizer and Amazon, you guys are the ones who actually got more business because of the
Yeah. We're not as lucrative though, I would say, but yeah.
And the thing is, people were expecting Pfizer and Amazon to get richer, but the construction industry, at first, people thought there's going to be a big downfall, and it was weird why. At first, I think they laid off some people, but then it started even blooming, and they started hiring, and everything got faster, and it was weird why. Could it be like the income gap? Especially in BC, we have a huge income gap comparing with other provinces in Canada.
I mean, I think my take was on it was that they got really scared, and then they just immediately, when the lockdowns happened, you know, there was this whole, everybody just started canceling projects, and these are projects that were planned, like to initiate, and then because they really didn't know like how construction would continue and progress with the pandemic, like nobody really knew. But nowadays, I mean, but at this point, like everybody's just used to wearing a mask and working on a construction site, and it just gets done. And it's not like the demand for housing has reduced or anything. So developers would say, you know, why do I need to stop? And then the government doesn't want to shut them down because that would affect the economy. So it just, all of that, like we were fortunate that was the case. Like it's not, I think, like it's not like restaurants where there's no choice, unfortunately, to close. But so that's how I see it. And then for like from a design side, you just work from home, right? So
also,
And those,
sorry.
go on, Amir.
No, go ahead. I'll just say it.
And those working in the site, they're working outside, so there's not much risk for them if they wear a mask and stay 2 meters apart. They're going by the regulations, so it's safe to work outside.
Yeah. Or even if it's inside, but they're still wearing a mask, then like say for renovations, then that's fine. Yeah.
Well, there were some outbreaks in construction sites. I don't know how much, but it was. I'm not going to say it's more than other places, because yeah, people are not chilling in construction site. They're not mingling. They're doing work, and they're definitely not there to chit chat. But I would say probably, and Jennifer is probably more savvy than me on this area. That's while the construction of like homes and whatnot, and the renovations and those kind of things that you talked about, the capital projects seem to take a hit because government incomes went down. Or I remember, I guess TransLink canceled some projects, and even YVR canceled some. I don't know if school districts did that too. I'm inclined to say yes.
For sure, no cancellations, but are reluctant. So before we can submit to the province, we can submit like a project definition report if we self-fund it. and then the province goes through it and then takes that, the Ministry of Education takes the proposal to the Treasury Board, and the Treasury Board says yes or no, right? But right now, the provincial government is very reluctant to approve new projects, and especially in Coquitlam, where there's not a lot of flat land left. So like say up in Burke Mountain, the school I was talking about earlier, has like one side of the property has like a 25-meter elevation, and the other side has like a 70-meter elevation from the front to the back of the property. And so it's going to be $100 million to remediate, to do the landscaping, to build that, to make it net zero. So let's just say that the approval process is taking an unusually long amount of time. I think we're at like 3 years now. So they definitely haven't like canceled anything, but the approvals are coming really, really slow. And that part is, it's tough, right? Because, you know, one school, $100 million. Like, what does that buy in terms of medical supplies, right? What does that buy in terms of COVID relief? So you can, and there's no profit to be made, right, from building a public building. It's not like you're going to be able to sell a piece of it. So for sure, the provinces, they came up with a new, not just a project definition report, which is used to be the old standard, but now they've come up with like a whole new additional process that you have to complete. And literally, I'm pretty sure just so they could be like, oh yeah, just one more report, just one more, so they could delay signing that check just a little bit longer. So I don't know. I think that that's going to be their plan for the next little while, is just holding off and prioritizing big construction projects. And they will definitely be looking at construction projects because it's a tough one, right? Because they have to build stuff to get reelected, right? They can't not build anything. But they have so many priorities right now that it's tough to say where the chips will fall when the big money comes down. So if anybody has any thoughts about how to convince them to build schools, I would love to hear that.
Well, we have Mohsen from Coquitlam. I guess Sam is in Vancouver, if I'm not mistaken.
No, actually, we are in Coquitlam, Tri-City area as well.
Oh,
We
okay.
moved there
Okay.
from Kitsilano.
Voila, you have two Coquitlam, two of your constituents here, Jen. So might as well. And if it's elementary school, in at some point they may have kids who want to use that. So just a thought.
So I have a question. In the neighborhood I'm living, in the past 3 to 4 years, there've been a lot of high-rises built, and the process is going on. There are like a few more under construction, and one thing caught my eye, that is the old ones, like the buildings built 3-4 years ago, are like 10 to 15 stories shorter than the new ones. My question is, how fast does this constraints change, and who changes it? Like, is it how is it done? And how many years? Like every 3 years, every 5 years? Because it's the one built 5 years ago, like 100 meters away from our building, is like half our building, and they've lost a lot of money because they couldn't build and profit from the rest.
That's more of a, I think that's more of a, those are urban planning policies set by the city, by the municipality, and there's a lot of politics around that, right? Like that's because there's a lot of money involved. But usually, like the way I understand it, this is not my expertise. I guess I've worked with a lot of urban planners, but the way I understand from them is you apply to the city, like usually architects do this, they apply to the city with a development permit, and then they propose to build a development of a certain size, which would have to, I guess, conform to the policies of that time. So, and that's the zoning policies, like the zoning requirements, like the certain, like there's like right now there are, I guess the way the city is laid out is zoned a certain way. So you, in this, if it's like a, I think it was like the most like those common ones are like, say, those residential zonings like RS1, and then you can only build like a single family, and then they can change these zonings every so often, and then if you want to rezone a property, you would have to apply, and then you would have to provide a rationale as how that impacts the community, and then there'll be a panel, and then the neighbors would come and, you know, see if you can convince them that you can do that. And sometimes there's a trade-off, like a developer might say, I'll build this huge tall building, but then I'll put a park next to it, you know, so that at least then the community gets something. So they'll pay with their own money to build something. So then that way the city gets convinced and allows them to do that. So that's kind of the dynamic of how those things happen. I'm not sure exactly I guess in that particular, in your particular scenario, but there's always like these kind of politics. There's a lot of trade-offs and so forth. I hope that.
Right. Yeah, thank
Hossein,
you.
did you say you were in the Burquitlam area?
Where I live in the Burquitlam, yeah.
Yeah, so the, like, Hossein was saying, there's trade-offs, right? So the developments there in the last couple of years, so one that got approved that was like 23 stories, 24 stories, because they agreed to build affordable living units that were going to be a combination of supportive housing for adults with severe intellectual and physical disabilities. So one whole floor of that building is dedicated to those people and a caretaker. And so because they were going to do that, they let them have more floors, right? And another one, they built like a daycare. So they let them have like X number of extra units, or they really do bargain. And in the last 3 years, especially, because of the push for more affordable housing, if developers come to the city council and say, hey, I'll build, 3 floors of below market rental housing, then cities will be like, okay, then you can have 3 extra floors of commercial, like, or you can have 3 extra floors of like market rate housing. And those projects that come forward that have like the mixed use are really popular, and cities are motivated to take that. But you're so right. Like a couple of years ago, building like a 20-story tower was like this big deal, and now you're seeing like 25, 26, 20, way higher. Yeah.
Most of them are more than like, I think most of them are around 30.
Yeah, that's nowadays that's the common size, I guess.
Yeah, thanks.
One more question, Hossein. What do you think about this modular construction or manufactured actually houses? Do you see future for them, like everything else? Things built on outside, like not offsite, and in a more economic way, efficient way, economic of a scale.
Yeah. I actually love those, and I met this steel fabricator that was trying to make a business out of doing that, and then it kind of gave me some idea of just the way, like how it works structurally and also in other ways, and I think it's great. But the problem is, I think for some reason it's just not very popular. Maybe people don't like it or don't know about it, and developers are not that into it because it's not very flashy. But I think it's very efficient. Like it's like from a structural standpoint, the way I understood it, that material is very high strength steel, so it works really well for like the normal residential loads we have, because they put these pallets, like they stack them up, like if you've seen those commercial ships, like they put up like 10 of them on top of each other. So that means you could build like a 10-story or whatever building, and then if you weld them together, I think you can get it decent system, and I think it would work well if it was properly researched. And yeah, I think I don't know why they're not gaining more popularity, because it's also sustainable too, because I think there's so much scrap of those things and they can definitely be put to good use, and they're not that expensive. The whole thing is like around $2,000, and how much space does that provide? Maybe like a couple hundred square feet or something, and maybe a bit more. So so that's like already like an apartment unit could be of that size. And if you put them next to each other, you can create like cutouts and create like rooms, and yeah, those are great in my opinion.
Thank you.
Yeah.
Is it? I mean, right now the modular thing, it's only for like homeless shelters, like sheltering the homeless. And from my understanding, the ones that they use are only good for like, I don't know, a few years. They're not permanent.
Yeah, I think we talked about that. I'm not sure why. Like, I mean, I just from a material perspective, I think you can pretty much, like, if you need to replace any of it, whatever it is, like if you put some, finishing on the inside or outside, whatever it is, I don't think there's any reason it wouldn't last longer. But I've been curious to know why that's the case. Like, why do they think it's only 5 years? But
I don't know. Jen, maybe, I don't know, do you have any insight? It's not your turf, I know, but yeah, I thought you might have an idea.
Honestly, I've been wondering the same thing, because we use sort of like the old-fashioned version of modular construction all the time. We call them portables, right? And we stick them on school grounds, and kids use them for 30 years. So it seems surprising to me that, and that's quite, I wouldn't say the construction of those or the implementation of them is exactly the same. But if 30 kids can use a similar structure for 30 years, I'm not sure why, but I'm not sure if the restrictions are actually like the materiality of maybe like the durability, or if the expectation is that those structures will only be used as a temporary solution on the way to like long-term housing. Was it like, I don't remember hearing anything about like the expiry of the structure itself. I think, was it a policy decision, or was it the actual structural decision? That's an your question.
I think it's a structure. I mean, I don't know personally, but talking to folks who are housing advocates, they said that these are only temporary housing. It's you can't really think of them as permanent. Like, the best material they use only lasts for like 5 years, and I did not really dig deep to see why. And there are some of those complexes near where I live. I can think of at least 3 within walking distance. And they're there. They've been there since we got the new government in place in 2017. Actually, the first modular housing that was brought in, that's just on the corner of Main and Terminal. But why they don't, and by the way, I saw them stacking the modules at the empty lots at Olympic Village, but where did they take them? I don't know, but I did not see any change in the size of the modular housing complex that was nearby. So I don't know. It's something that I'm curious about, but not something that I know enough.
Mm-hmm. Yeah, me neither. Actually, Hossein, maybe one more question. I promise this one will be less
No, it's all great.
expansive than the other two. So we're just talking about modular construction, right? And we're sort of referring to that as like the whole unit, you know, just like the whole thing. Now, what are your thoughts about that kind of like sort of pod sort of modular construction in comparison to say things like tilt-up walls or the interior walls that, have you heard of like the DIRTT, the ones that like they're interior walls that you slide in and they are technology compatible, so they're like pre-wired and they're basically like panels you just like slot in and out. So what is, like, when we're looking at like that kind of construction, that kind of modularity, not just say like the whole building, but the actual pieces of the building being like Lego blocks, sticking in and out, pre-made Lego blocks. What are your feelings about like the flexibility of those and the sustainability of those construction methods?
I think the only trade-off is the architectural aesthetics when it comes to those. I think in other aspects, it's all probably mostly preferred by engineers than just a regular construction where the architect wants to do all these crazy things, right? So, and then sustainability comes to the material that they're made of, and I don't think the material is going to be that bad. So there's really not much else to it, like I mentioned. So I think they're good, and they're going to be cheaper. They're going to be built faster. Like all of these are pros, and like maybe I'm biased, but I don't see anything wrong with it. Like, yeah. So that's but maybe the only issue is that just nobody's used to it, because all the construction professionals and all the construction seniors in the industry right now, like you have concrete guys, you have carpenters, you have steel workers, like none of these like really work with these as much. So you would have a hard time finding competent trades to do your installation. I think that's probably the biggest issue. But so it has to be an investment of time to build these proficiency. You know, with people, you know, train people that are good at this stuff, and then they can build them fast. But I don't think that's going to be an issue. It's just a matter of investment.
Awesome. So what's our takeaway?
Takeaway. Yeah, I had to. I would say I think people should be more aware of how their living environment is built. I feel like just in general, like I think people don't quite know really, in my experience, like you know, how their buildings are built, like how their walls are built, how their floors are built, and what are the implications, like maybe something that's right beyond their drywall, like they have no idea. And that's kind of how I felt when I entered the industry. And I think because these things have a lot of they affect a lot of our life and a lot of our efforts and our resources. So I would say maybe there should be more construction awareness, even though it's not very flashy. But so that's the best takeaway I can think of. And also more investment of technology into construction, just bringing back to the topic. I think technology, like construction, can benefit a lot from technology at the stage that it's in at the moment. And we need more software engineers, computer engineers, software developers to kind of invest and make these construction procedures more efficient. And I think that would be in the benefit of everybody. Construction industry, I think maybe like any other industry, that maybe like any other traditional industry I would find it a tough industry in terms of margins. I think, Amir, you were saying aviation industry is similar.
3 to 5%.
So it's very similar. It's hard to make it, like, it's hard to break even, make it work. And yeah, like, I think, and that makes things challenging. Like, that makes innovation challenging. That makes, so I don't have a solution right now, but I think if we were able to help with that, I think we would have more say on how our built environment is built, then maybe it will be better for all.
Fun. Well, thank you so much. Thank you everyone for coming. Join us next week at 6 p.m. On Wednesday with a talk from Mahsa Sharifi. Thank you, Hossein. Just to be clear, there was no nepotism, no family preferential treatment was involved. Nod, nod, wink, wink.
Yeah.
Yeah, and Hossein, can you please send me your takeaway by text later? I tried to capture the gist of it, but I think I did not do justice. Okay,
sure. All right, thank you guys for having me. I really enjoyed this talk, and thank you for all the great questions and listening in. Spending hours.
Thanks, Hossein.
Thank you everyone for coming. Stay safe. All the best.